Today we start chapter random variables and distributions, okay, which comes under statistics. Here statistics is divided into two, that is descriptive statistics and inferential statistics. Okay, in descriptive statistics we have already learned how to calculate the measures of central tendency like mean, median and mode, and we have also learned how to calculate variance, standard distribution and so on, right? So in the inferential stats we are going to learn how to draw inference, right? How to draw conclusion from the given data. Okay, so whatever the syllabus we have in this, that comes under inferential stats. Okay, here we'll be learning about how to draw the conclusion from the given data. First part, we are going to learn about random variables and about different types of distributions. Okay, what is a random variable, or what are the types of random variables we have? Okay, and what types of distributions we have? What is the importance of random variables? What are the different types of distributions we have in this? Okay, then in the next part we are going to learn about sampling theory and what is the importance of sampling, okay, in that particular unit. And in the next we are going to learn about hypothesis and estimations. Estimation is one where we guess, right? In the test of hypothesis, we'll have the values, we'll test whether those values can be acceptable or not, whether those values can be acceptable or rejectable. Okay, in that way these three units are there which belongs to inferential statistics. Okay, as we all know that the field of statistics deals with the collection of data, presentation, analysis, and by using these data we try to give the conclusions. This is a very important topic for the engineers. Okay, when they enter into their workplace, they'll soon realize about this importance of the statistics, starting from designing the product till making the products to work. At every stage they are going to use the statistics in one form or the other. Okay, so the engineer need to learn about this inferential stats. This stats is being used in our day-to-day life, knowingly or unknowingly. So now we'll see about the statistics, and then we are going to see about the importance of random variables and about different types of distributions in this particular unit. The field of statistics deals with the collection of data, presentation, analysis, and use of data to make the conclusions and draw data to make the decisions and draw valid conclusions in the presence of variability, comma, solving problems and designing the products. Statistics can be described as the study of how to make inferences and decisions in the case of uncertainty and variability. Okay, the role of statistics is indispensable. Okay, that one cannot do without, means without using the stats, okay, they cannot do anything when they enter into the field of engineering. All the practicing engineers soon after they enter into workplace, they realize the importance of statistics, starting from designing the product to making the product to work. Now we'll see about the random variables. Variability is omnipresent, means being everywhere in the business world. To model variability probabilistically, we need the concept of random variable. A random variable is a numerically valued variable which takes on different values with given probabilities. As variable is present everywhere in the business world, okay, to model such variability probabilistically, we need the concept of random variables. Some of the examples we can take of variability are the return of investment in a period of 1 year, or number of customers entering into a store in 1 hour, etc., where there is a variability. Okay, we cannot predict what is going to be the return of the investment in a period of 1 year and the number of customers entering into the store in 1 hour or in 1 day and so on. Okay, in every case there is a variability, right? So to model such situations or such variability probabilistically, we need the concept of random variables, where random variable is a numerically valued variable, okay, which will take different values with some given probabilities. Okay, now we'll come to actual definition of random variable and how many types of random variables are there, okay, and based on that we'll solve some problems. Now we'll see about random variable. A real number x associated with the outcome of a random experiment is called random variable. A real number x, or a real function x where each sample point is mapped onto some real number, then it is also called as a random variable. Or we can also define in another way, that is the quantities which varies with some probability. If they are varying with some probability, that is also called as a random variable. Or a real function capital X where each sample point in S is mapped onto a real number is called a random variable. Or the quantity or quantities which vary with some probability are called random variables. Okay, in these three ways we can define what is a random variable. Now we'll see an example of a random variable. How exactly we can define that random variable by taking an example. Suppose two fair coins are tossed. Then we know that the sample space S is equal to, okay, sample space will contain 4 sample points, head head, head tail, tail head and tail tail, right? So head head, tail tail, head tail, tail head. Mainly these random variables we use for the denotation purpose. Okay, what I said here, a real number x associated with the outcome of a random experiment, a real number. Okay, I'll give x equal to 1, x equal to 2, x equal to 3 and so on. Okay, here I suppose that the 2 fair coins are tossed, then we know that the sample space is head head, tail tail, head tail, tail head. And if I am supposing that, let capital X be a random variable denoting heads. If X is denoting heads, then if I write X equal to 1, it means getting one head. X equal to 1 is nothing but getting one head, right? If I write X equal to 2, it means getting 2 heads. X equal to 0, getting no heads and so on. Then P of X is equal to 1. The chance for getting X equal to 1 is, see that in 2 cases we are getting one head, tail head, head tail. So therefore out of 4 cases, we define the probability as favorable number of cases by total number of cases for the happening of the event E. Right? Favorable number by total number. How many are favorable for getting one head? 2 cases. How many are the total cases? 4. So therefore, probability for getting one head is equal to 2 by 4, which is equal to 1 by 2. Then P of X is equal to 2. Means probability for getting 2 heads. How many chances are there for getting 2 heads when 2 coins are tossed at once? See that the sample space contains only one term of such type, head head, out of 4 cases. So therefore its chance will be 1 by 4. P of X is equal to 0. It means probability for getting no head. It is happening in only one case, that is tail tail. No head is occurring there, right? So therefore I can say that its chance is 1 by 4. So its probability distribution table will be like this. X equal to X, P of X is equal to X. X equal to 0, X equal to 1, X equal to 2. When X is equal to 0, what is the chance? 1 by 4. When X equal to 1, what is the chance? 1 by 2. When X equal to 2, what is the chance? 1 by 4. Now see that the sum of the individual probability is equal to 1, 1 by 4 plus 1 by 4 plus 1 by 2, which is equal to 1. Right? This is how we define that random variable. Okay, and we can also see that the example of the random variable, how it describes about random variable in this. Okay, mainly it is used for denotation purpose here. Okay, as we are going to learn about the distributions, in that we use this concept of random variables. So here we have learned about random variable. Then we'll write a note. Random variables are denoted with the capital letters and their corresponding values are denoted with small letters. That's the reason I wrote here capital X is equal to small x. Small x will represent the value and capital X represents the random variable. If capital X comma capital Y are random variables and A and B are constants, then X plus Y, XY, X plus A, okay, AX plus B, AX plus BY, so on, are all random variables. Okay, when X and Y are random variables, their sum, their product, their linear combination, that also becomes random variable. Okay, cumulative distribution function. You have already heard the word cumulative in your lower classes, right? The same concept is used here also. If capital X is a random variable, taking the values minus infinity less than x less than infinity, then the function capital F of x, capital F of x is equal to P of x less than or equal to x is called cumulative distribution function. Okay, if capital X is some random variable taking the values x lying between minus infinity and plus infinity, then the function capital F of x, that is capital F of x is equal to P of x less than or equal to x is called cumulative distribution function. See the term what I wrote, P of x less than or equal to x. It means minus infinity to x. Right? As x is varying between minus infinity to plus infinity, here P of capital X less than or equal to x. It means minus infinity less than x less than or equal to x. Cumulative. Right from minus infinity, okay, whatever the values you get up to x, you have to sum them. Then that gives the cumulative distribution function. Okay, it is called as cumulative distribution function. It is written as CDF. And it satisfies the following properties. It satisfies the following properties. First one is P of A less than x less than B, or P of A less than or equal to x less than B is equal to f of B minus f of A. For a continuous distribution, P of A less than or equal to x less than or equal to B is same as P of A less than x less than B or with any equal to signs. Okay, so P of A less than or equal to x less than B, I can write it as f of B minus f of A. Then second is, this capital F of x value will always be greater than or equal to 0 and less than or equal to 1. Or I can write 0 less than or equal to capital F of x less than or equal to 1. As we wrote that cumulative distribution function in terms of the probability P of x less than or equal to x, it also has to satisfy the properties of probability. That is, we know that probability lies between 0 and 1. So therefore, the cumulative distribution function value also should lie between 0 and 1. Then third, if x is less than y, then f of x is less than f of y. Like suppose 1 is less than 5, then definitely the cumulative distribution function f of 1 will be less than f of 5, right? Then 4, f of minus infinity value is 0 and f of plus infinity is equal to 1. As its cumulative distribution function value lies between 0 and 1, okay, at minus infinity its value will be 0, at plus infinity its value will be 1, because minimum value is 0 and maximum value is 1. So at minus infinity its value will be 0, at plus infinity its value will be equal to 1. Okay, and for continuous distributions, P of A less than x less than B is same as P of A less than or equal to x less than or equal to B, which is equal to P of A less than x less than or equal to B, which is same as P of A less than or equal to x less than B. Okay, in the continuous sense, these are all same.